Okay, good evening. Let's continue our class. Let me share the screen, entire screen. Okay. So last week we covered about intrusion detection system. I have to be honest now. I think I will not be able to cover all the cybersecurity stuff because we only have like what 7 meetings, 6-7 meetings, so it's a bit difficult. So we already covered this one. Today I like to cover this one. Okay, basic data security, which is basically encryption, data encryption basically. Okay. Just to give you some example why it is needed, because basically people can sniff, people can see what we are sending over the network, and then to be able to protect the data, we need to encrypt the data basically. So to give you some idea, let me see. I have my sniffer installed here. So normally I have to use Kali Linux. Now I will, let me see. I have Wireshark. Okay, Wireshark. Okay. So Wireshark already installed in my operating system. Okay. Wireshark is basically software to sniff the packet over the network. So you can download Wireshark. Basically, we can search Wireshark over the by googling. We can find Wireshark. You can download. You can install Wireshark on Windows. I think Mac OS and Linux. So it's in all operating system. And then we can see what kind of packet sent over the internet. Okay, so now I have Wireshark running. Then I can capture the packet on my network. So this is basically the packet sent over my network. This is the number of packet. This is the time. This is the source, destination, type of protocol, and some information about the protocol. If we learn about networking, then normally the the teacher will tell you that there are 7 layers of protocol to send data over the network. We can see actually the actual layer. So not many lecturer, not many teachers will describe about in the inside of the layers. So the layer is actually this one. Let me stop capturing first. Stop. Okay. I just click any packet. This one. See, I have 1, 2, 3, 4, 5 layers. Okay. This one is physical layer. The next one is data link layer. This one is actually MAC address of the source and destination. This one is network layer. It run Internet Protocol version 4. This is the source, and this one is the destination. This one is transport layer. It has user datagram protocol. The source is, the port number of the source is 3478. The destination is 49854. Okay, the actual data is this one. So basically, we can see what was sent over the network. Let me see if I can see something. Okay, no payload, no actual data here. Okay. I already run a server here. Let me see, where is the server? This one is a server. Okay, this one is a server. Okay, let me see if I can see the IP address of the server. Then this particular server, it has mail server, so I will send email, and then we will check if whether we can see the content of the email. So the IP address of the server is 192.168.0.209. Okay, so 0209. Okay, we can browse the. It has a webmail 192.168.0.209. Okay, squirrel mail. So it has squirrel mail installed. Then I can log in and check my mail. For example, this one. Let me. Okay, no problem. Okay. Now it has some mail here, and then I just received an email from President of the Indonesian President. Please come to the palace. Just kidding. Okay, I delete this one. So that's how to send what's that? Spam or hoax. Okay, it's very simple. Okay. Now, so I will send email here, but while I'm sending the email, I will sniff the packet. Okay, capture, start. Continue without saving. So okay, I capture all the packet now. Now I will communicate to the server. The protocol used to send email, you can check the protocol from the RFC editor. Basically, all the protocol for communication over the internet is an open standard developed by the community. Basically, it's developed by the Internet Engineering Task Force. This is the internet main body for designing the internet. IETF is currently held a meeting in Bangkok, so it's from a couple of days ago till couple of days for the next 3-4 days. And then one of my colleagues actually give presentation in this meeting. Actually, they asked for 2 Indonesian to give presentation in this meeting, but unfortunately, one of the other Indonesian is still doing his master's degree, and he's having difficulty to spare time to go to this meeting. So only one actually go to this meeting. It will. I have his slide actually. So he will describe about the fiber optic to the villages. Where is it? Let me see. No. Let me see if I can see it here. No, this one. Okay. This is his slide actually. Just gives you some idea that we actually quite active in the international community. So this is the internet in the village. Dadang will do some storytelling on how to build the internet in the Indonesian villages. He actually running a fiber optic in the Indonesian village. So this is when they deploy the fiber optic in the village. This actually fiber optic cables. This is the struggle to build these things, and this is the topology of the network, and this is the investment, and this basically the cost. So normally, foreigner will be surprised that the internet cost is very cheap in Indonesia. So only what, a fraction of dollars per day. So this is brutal actually. So this is what we are doing. Okay, now back to the sniffing stuff. So I will start sniffing. No, it's already sniffing now. Now the standard for sending email is in RFC. RFC is request for comment. The standard for sending email is SMTP. And then we can check the protocol using this. We can read the protocol. This is the first RFC for SMTP. It's written by Jonathan Postel. Okay, now, so it's written by Jonathan Postel. It's called Simple Mail Transfer Protocol. We can see the example how to do it. So basically, this is how to do it. Okay. So the internet, when computer interact with other computer, it will adopt standard protocol, and the protocol is basically not that complicated. So basically, we interact with the server by typing the command. So we basically type the command. The server will respond to us, to client. So this is from client to server. The server to client basically will send numbers. 2 means okay, basically. If there is a problem, normally the number will start with 4. So 4 is not okay. Okay. So basically, for sending email, we can type mail from receipt to, and the email address, and then we can type the data and finish by press enter dot enter. Okay, so we will do that now. I will connect to the SMTP server, which is 209. The port number of SMTP is 25. So I connect to 25. Now it's connected to the server. The Wireshark still sniffing the packet. So, and then I will have to type hello. This is hacker.com. And they said 2. It responds with 2. That means okay. And then mail from. I can say something like this: hacker@hacker.com. Receipt to. My email over there is onno@korban.com. Data, and then the data can be like this. I can say from anyone, basically. I can always say prabowo@istana.go.id, fine, to onno@korban.com. It can be anything, basically. So it doesn't matter. It can be anything. After 345 here, 354, it's basically a text file. It doesn't recognize anything, so I can say onno@home.com. Subject hello, how are you? Hope everything is okay. Please visit me at the palace. Okay, and then the president write his signature, for example, like that. And then to send, just enter dot enter. That's it. It send the email. Okay. Now, let me see if I can. So this is basically big problem because anyone can sniff, and when anyone can see what is sent by email. Okay, now I capture stop. Let me sort the IP address with 0209. Oops. Oops. Too many. Okay, this is the one. Okay. See this? There is SMTP. It says OK here. So for example, I catch one of the packet, this packet here. It has 5 layer protocol. Yes, catch 5. It knows that it uses SMTP, simple mail transfer protocol, and inside the packet it has 250.212.1.5 OK. In the hexadecimal, we can read it over here. This is the hexadecimal format of the packet. So this is the more human readable format. This is like machine format. So basically the packet is in binary. We can convert it to hexadecimal, and we can also what's that? Translate into machine human readable format. Okay, so basically we managed to capture one packet. If we want to see the whole transaction, just analyze, follow TCP stream. Oh, where is it? Okay, that's it. So slow, eh? So I can see what was sent. Okay, so it's very easy to sniff, to get anything you send over the network if it is not encrypted. We can check whether the email is received by the destination. Okay, this one. Okay, we can reload this one, so it can see I received the email. We can type hello. As I mentioned in the previous lecture, we can actually do some forensic of this problem by typing this one, view full header, and then we can see the origin of the sender of this email, which is this one. So this is the actual sender. Okay, and the IP address is 192.168.0.3. Okay, so we know who's responsible for sending the email to the Indonesian president. Okay, now how can we solve this kind of problem? Okay, let me show you. This is where we will cover this one. Okay, how can we solve this problem? For example, let me see. I will send email without encryption, test, and then here test. Okay. So I'm sending email from Onno to Onno at Indonet. Okay, send. Okay, itu send. So I received the email. We can check on this one. We can see the same thing basically. Where is it? Okay, this one. No, it can only see the header only. Okay, anyway, and this one is more complete. So we can see this one. So I can read the email now. Can I see the content of the email? I should be able to see it by view source. When viewing the source, so this is the header. Okay, let me increase the font size. Oops. Okay, so this is basically the header, very similar to the one that I sent locally. See, and then we can see the if there is no encryption, I can read. Any hacker can read the email, plain text email. Okay, how can I encrypt this one? Very simple actually. Here I have to enable the end-to-end encryption facility for the email. The same thing happened with HTTPS. The same thing happened with WhatsApp, for example. It has end-to-end encryption. So the same technology, the same method is used in many type of communication. It can be web using HTTPS. It can be WhatsApp. It can be email. It can be anything. Okay, including if I do remote login to other machine, I normally use SSH, which is secure shell. Now, to activate the encryption, I type the account and then do end-to-end encryption here. So the key is not generated yet. I can add my personal key, create new key, continue. It will expire in 3 days because this is only for example. So I make the key expired in 3 days. Okay, the key size is quite large, 3072 bits. It's quite long, so it's more difficult to hack, and I can generate the key. Confirm the identity, so it will generate both public and private key. Okay, confirm. Okay, it will take some time to generate. Okay, the key is generated successfully. This is the actual key. I can use the key to encrypt the communication. Let us use this key to encrypt the communication. Okay, now I will do the same thing here. This message will be encrypted. Okay, now I type this one. How can I encrypt this one? All I have to do, just type this. So this one, the encryption button is not pressed yet. All I need to do, just click this one. Okay. Okay. Now it is encrypted now. That's it. As simple as that. Or it has several options. I can encrypt the message. I can encrypt the subject. I can digitally sign the message. So I can do these things. Okay. At the moment, it will do all of these things. Okay. Now I send this thing. Send. See this? It becoming ... Okay, it's no longer readable because the subject is encrypted. It's ... Because I have the key, I have the private key. I can click this one and then it will check. Click this one. See this? There is a menu here which is Open PGP. Open PGP. I can check this one. It says good digital signature. It tells us that the signature is good. We can view the signer. We can see the signer, the one that sent the key is me, Onno@indo.net.id. Okay. Type OK, and then I can check also the message is encrypted. We can check whether the message is good or not by checking this one. So the signer and the actual person that encrypt the message is the same basically. Okay. Now, how the message look like? We can type this one. Click View Source. See, this is the big difference from the previous one. We cannot read the message anymore. Nothing. So all the text is encrypted now. Okay. So that's how the encryption works. Okay. Now, that's one thing. We can always send the message by we can send the message different. Okay, for example, this message will be readable. It has a digital signature. Okay. how the actual digital signature looks like, I can do something like this basically. Digitally signed. That's it. So the message is not encrypted. The subject is not encrypted, but I digitally sign the message. Okay. I will send the message now. Okay, see this? This message will be readable. It has it has digital signature. So I can see this one. It has digital signature over here. It attached. Okay, let me see how it look like. Okay, sorry. All I need to do is view the source. Okay. So we cannot see the message actually. See this? We cannot see the message. But there is a public key block and there is a signature block. So if someone tell you that a letter or a paper is digitally signed, the actual digital signature is like this. But normally they will convert the information using QR code or barcode or whatever, or URL to make it more human. So basically, if we send things, if we sign things, we will send the public key for checking, and then this is the actual digital signature. Okay. Where is the message? This is the actual message here. This is the actual message. We cannot read it, but it will says content content transfer encoding is base 64. So let me see if I can. Okay. So it encode in base 64. This is the actual. This is the actual message here. Copy, and then. Let me see if I can decode. Decode base 64. Okay. There is a website for decode and encode base 64 online. Just paste the message here and then decode. See this? This message will be readable. It has digital signature. That's it. So base 64 is not encryption. Basically, is conversion of format. It's not encryption. So it can easily decode and encode. Okay, so that's how we send things. Now I have around 1 hour, so I will give some presentation on. Let me see if I can. Undo. I will check whether I can show you some actual digital signature. Oops, sorry, wrong. Okay. I don't need to read this one. So this is the digital signature. Wow. Okay. Okay, I have to log in. I forgot the password. So okay. Anyway, so basically there is application in many institution to do. Basically, I like to show you how to sign a message digitally. Okay, so we can check Google digital signature in document, how it looks like. So basically it will looks like something like this. Let me see. See? Oops.
Let's start the day, shall we?
Okay. Basically it looks like something like this or something like this. Digital signature. Not the actual signature, but it can be normally will show you in looks like QR code or something like that. So not this one, but more on this kind of thing. Let me see if because I don't have one in my computer, so I need to download. So the example. So basically, it will be look something like this. The actual digital signature is the one I showed you before. Okay. Now, what's the concept behind all of this? Okay. Okay. I think I have to show you the actual regulation in Indonesia. For digital signature, you can download the Information and Transaction Electronic Act. Okay. We have where is it? We have Information and Transaction and Electronic Transaction Act. I think something like this one. Okay, so you can download here. But basically, it has, let me see, it has electronic certificate, it has digital electronic, which is digital signature, and it has the electronic certificate, it has what? Certificate authority. This one is certificate authority. It has signature. Oh, by the way, this is the only act that govern the signature. If you see the other act, there is no act in Indonesia that govern the signature. So the signature is only governed in digital signature, basically. Okay. So we need certificate authority. We have electronic transaction. We have electronic certificate, and we have digital signature. So how it relates to one and another? You can download the my slide from this website. Let me see if I can. Okay. Okay. You can download from this website, especially this one. Security, and this one actually, the last one. Okay, let me see the copy link address and put it in the chat. Okay, so you can download this slide. Let me see if I can show you the slide. Okay, oops, sorry. Cyber security, and where is it? This one. Okay. Okay. This slide is created in the year 2000. So this slide is about what? Now 2025. So this slide is about 25 years old. Okay. And this at that time, we Indonesian is trying to make the cyber law. So and then finally we end up with Information and Electronic Transaction Act. Okay, so this is actually the origin slide where we are trying when we are trying to set up the cyber law in Indonesia. Okay, now we'll skip everything. So many of these things is about electronic data interchange. It's not really used now. Basically, we use XML and JSON. So no longer, so electronic data interchange is replaced by XML and JSON, and we encrypt the transaction. That's it. So not as complex as in, electronic data interchange. It's very simple. Now, For this one, I think I have to show this one. Okay. So I will show you what the concept of public key infrastructure. So we generate key for the email, I generate the private key and public key. Now I have to tell you about the public key infrastructure and certificate authority. Certificate authority is mentioned in the Act, the Information and Transaction Electronic Act. So I will describe about this. This particular slide is actually written by Arianto Mukti Wibowo. He's already passed away. Before he passed away, he asked me to distribute his knowledge as long as possible, basically. Okay, so I carry on his wish to distribute his knowledge. So you can search his name in the in Google, and it will find his name in University of Indonesia. Okay, at that time we all use Microsoft. What is this? Microsoft. I forgot. Basic Microsoft browser, and in security zone we have this security zone, and we can set whether we have digital ID or so basically we can get the certificate or digital ID, and at the server side, the server can also have digital ID. So this is how we set up the setting, the certificate and everything. Now the other browser we use at that time is Netscape. It has option for certificate. We have certificate for end user, yours end user, other end user, website, and signer is the certificate authority, basically. Okay, so this is the thing that we use at that time. How about today? Yes, we still have the same thing, basically. We can click this setting, and we can go to, where is it? Setting, and we can go to privacy and security, and then we have security, and then we have manage security keys, then not this one, manage certificate. So we have certificate, our certificate, server certificate, and certificate authorities. Okay, not many certificate authorities we can see here, but basically many of the authorities is in the US and Europe. Even the Indonesian authority is not recognized by the browser. That's our problem in Indonesia, because the certificate authority in Indonesia is not recognized by the browser. Yes, we can import the certificate, but that's not convenient. We need to negotiate, do some negotiation with the browser, the developer, so the Indonesian certificate authority can be built into the browser. Otherwise, we have to use the US or Europe certificate authority. But this is forced by the Indonesian law. Actually, we need to have certificate. There is a certificate authority. The problem is the authority is from the other countries. Okay, now back to this one. Now, in the security, we have several issues, but this is the old ones. Normally, we encourage the issue is privacy, authenticity, integrity, and non-repudiation. But later, they changed this issue into CIA. CIA in cybersecurity. So CIA is confidentiality, integrity, and availability. In the past, we use this one. I tend to lean towards this one. So basic privacy and confidentiality is not much different. Okay, integrity, same integrity. Authentication, authenticity. Basically, we can authenticate the other side whether this is real or no or not. And there is no non-repudiation in the later concept. Okay, so this is a big problem actually. Non-repudiation basically, mind you, this is all of these things is basically soft copy, and we know in soft copy we can change the information. In non-repudiation, the technology have to make sure that all soft copy file can be presented. We can bring all the soft copy to the court, and the court and no one can dispute that. Okay, so it will be accepted. The problem is this is soft copy. We know soft copy is easy to change. We can edit anything in soft copy. How can we build a technology in a platform or file that can be edited, bring it to the court, and the court will accept that? So that's the problem. Okay, but this problem is no longer of interest now, but actually that's the big problem. Okay, so this one is the most important one for me. Okay, because everything is about law, and we have to go to court and everything for those things. So basically, the confidentiality is to make sure that only those who are doing the transaction can read the data. Other than that, cannot read the data. Okay, then that confidentiality. Integrity, the technology have to make sure that if there is anything changed in the document or the information or the message, the system will know that the integrity has been violated or something. Okay, so we have to make sure that it can check the integrity of the data. Okay, the technology have to make sure the integrity of the data can be checked. And then the authenticity is basically if there is someone sending email like so this slide is written 25 years ago. At that time, the Indonesian president is Gus Dur. So if there is someone receive an email from president at gusdur.com, one may ask, is this the real Gus Dur? For example, I received email from Prabowo at palace.go.id. Is this the real Prabowo or not? So the same thing. We need to be able to authenticate the sender and the receiver of the email. And it has to be able to check whether the sender is the real one or it's not the real one. And non-repudiation is we can use the soft copy as evidence in court, and no one can deny that. Okay, that's the difficult one. Okay, let me show you how the encryption is done. So basically, there are several types of cryptography and encryption. The simplest one is symmetric cryptography. So the key for encrypt is the same as the key for decrypt. Decrypt use the same key. The problem is how can we send the key from sender to receiver? If the key send simultaneously send side by side with the document, that's creating a problem because anybody can read the document if they have the key. So the problem is how to distribute the key. Okay, now So this is the symmetric cryptography. The other one is public key cryptography. So basically, we have two different keys: public key and private key. So the previous one we have one. The previous one we have one key. For encrypt, decrypt, one key. On this one, we have two keys. Okay, public and private. This is more difficult to implement. It will require more CPU time, CPU resource. So normally we use this to encrypt small information, while this one we can encrypt like large information. Okay, but this is the most important one but normally because it will consume a lot of computing power, normally we encrypt for small information. We can use this public key cryptography to sign a message, to send email that only the receiver can open the email. So the email, the server admin cannot read the email, although it will go through the server admin, or any hacker in between cannot read the email as well. Now, in asymmetric cryptography, basically we have public key. If we want to, so public key is distributed. Anyone can have any one public key. So if we want to send a certain message to certain person, we have to ask the person to give them the public key, and then we can encrypt the message using the destination public key, and then the message sent to the destination, because the destination have the private key, and then it can open the message. Okay, so this is basically not a twin, it's basically a couple between public and private key. So it generates a couple of key couple, basically, public and private key. The public key can be distributed. The private key has to be protected. Okay, now, so that's the asymmetric cryptography. In the past, 25 years ago, we only have like 128 bits. It's already very difficult to hack. Takes so many years to brute force. Okay, now we have 3070 something bit, so it's more difficult to crack. Okay, 25 years ago we have RC4. If we use RC4, 128 bits takes this number of years to crack. So it's difficult already. But now it's much more difficult, because we normally adopt 2000 something bit, or 3000 bits, or 4000 bits. So it's more difficult to hack. Okay, that's the public and private key. Now the digital signature concept is like this. Okay. So basically, if we have a message, we calculate the message. We calculate the message signature, basically the signature of the message, by hashing the message. So basically, this is a hash of the message. Normally, we can use MD5, something like that, for hashing the message. So we can see the this is the hash of the message. Every message has different hash. If there is a single character change in the message, the hash is different. So that's the key. Okay. Now, to make this one to become a digital signature, what we'll do is encrypt this one using private key, our private key. So private key, basically, it has two information. So digital signature, basically it has two information: who signed the message and which message. And digital signature can be detached. We can detach the digital signature from the actual document, and we can check the document separately. Okay, so it can be detached from the document. Now, the digital signature is authentic, can be used as evidence in court, is only okay for this particular document or its copy. So it can be copy, fine, no problem. It can be checked by anyone. Very easy, because we can get the public key of the signer, and then we can check whether this is the real the particular person or different one. So we can check by checking using the public and private key. Okay, so that's the digital signature. Now we have digital certificate. Basically, is if it is real world, it can be person identity or driver's license, something like that. But this is in digital world. Basically, we have ID number, country, organization unit, person name, the expiry date, and it has public key in the digital certificate, and the digital certificate signed by certificate authority. So certificate authority will sign the certificate digital. So certificate digital, it has all the identity of the particular person. It has the public key, the expiry date, and the signature of the certificate authority. So that's the digital certificate. Okay. What's the importance of the digital certificate? We can have close communication pipe between two different subject. It can authenticate each other. It can be used to check and create digital signature. The important thing is it can generate what? Oh, it can generate, for example, passport, digital passport. Okay, so it can generate digital passport. So the ID behind the technology, or the ID behind digital passport, is this one. Okay. Having said that, if the equipment have all the public key of the person, then we can do offline verification of the digital passport. So digital passport can be verified offline if the system has all the public key. But if it is digital passport, it must collect like couple of million Indonesian digital public key. So it's quite a challenge, but it can be done. So we can do offline verification. It can be used for digital passport. It can do digital those things. Now, let me show you how the transaction look like. Okay, this is how the transaction look like. Let me check. Okay, now, if there is no encryption, all we need to do is just type the message, click send. Okay. So type the message. Okay. Click send. The message sent, and anyone can read the message. Hacker can read the message, and the message arrive at the other end, and the other end can read. That's it. No complex transaction like this. What we do when I do something like this, let me close this one. Okay. Whenever I sorry. Whenever I create a message like this and click encrypt this one, just click encrypt this one, this is what happened. Okay. So a message will be hash. So hash function will calculate the message digest, and then it will encrypt it using private key of the sender, which is Alice, and then we have digital signature. So to get the digital signature, we go the message has passed through several process: hash, message digest, encrypt using the sender private key, digital signature. The message plus digital signature and digital certificate combined. Okay, all of this document encrypt using symmetric key. This one is not not public key. This is symmetric key. Then we get the encrypted message. Why we use symmetric key? Because it's more, it's not consume the CPU as much as public-private key. So the public-private key only encrypts small, only encrypt the message digest, which is very small. The symmetric key is used to encrypt the whole message, which is very large. But symmetric key is not consuming a lot of CPU power. So we have the encrypted message using symmetric key. Now we need to send the symmetric key, and we have to make sure only the destination, the recipient, can read the message. So what we do, the symmetric key will encrypt using BOP, which is the destination, public key. So we encrypt using public key of the destination. We have digital envelope. So we have encrypted message, we have digital envelope. The BOP public key, we can get the BOP public key from the BOP certificate. It has public key, and then we can encrypt the symmetric key using BOP public key, and we have digital envelope. The encrypted message and digital envelope sent by email. No one can read the email, and then we can open the email by decrypt the digital envelope using private key. So when we encrypt using public key, decrypt using private key of BOP, and then we will have the symmetric key again. Having the symmetric key, we can decrypt the encrypted message using the symmetric key we get from digital envelope. Okay. Now, decrypting the encrypted message, then we can get the message, digital signature, and the certificate of the sender. Okay. At this point, we can actually read the message. Now, we need to check whether the message is not corrupted, not hacked, there is no change during the transmission. To check the message, we pass the message into hash function. We get the message digest. From the digital signature, we can decrypt the digital signature using Alice public key. From Alice certificate, we can get the Alice public key. Using the Alice public key, we can decrypt the digital signature, and then we can have the message digest. So we have two message digests, one from digital signature, one from the hash function of the message. We can compare these two message digests. We can compare. It must be same. If it is the same, then the message is still is not compromised, still okay. Okay, that's it. It's quite complicated. So I have 30 minutes. I will show you how to do it. I will check if there is any question first. Any question? No? Okay. I like to show you. I will do some demonstration using command line in Linux. see. Okay. That's why never do a banking transaction on public network. Yeah. Yeah. Don't use public free Wi-Fi to do banking transaction. It's okay if we do using the our phone. It's fine, but not using Wi-Fi, using the cellular network. Okay. Now let me do some demonstration using command line. Okay. Oh, back here. Okay. I will use GNU PG. GNU PG. Oops, sorry. GPG. Okay, this one. It has mini how to. Now this is the okay. Let me do it more slowly. Okay, you can go into OnnoCenter.or.id. Type in GPG in the search. This one, search module, and then we will go to GNU Privacy Guard. Okay, then here it has several how-to. We can read this one, mini how-to. I will do some demonstration using mini how-to. So the previous one, I show how to do these things on Thunderbird mail. This time I will show you in command line. Okay. To generate key, we can do something like this. We can generate the key. Let me see if I have some key here. Okay. Let me see if we can do GPG key list. Just want to make sure it has key which is not expired. Oops, there is no key. That means I have to generate one. Okay. Okay, I will generate the key. Okay, real name. Email address. Okay. Okay. Password 123456. 123456. Okay. Takes this one, so it complained because I only have 6 character. It should be at least 8 character long. Well, okay, this is only for demonstration. So so now I have the key. And it will expire in 2028, which is 3 years from now, which is too long. Okay, now having the key, then I can do something like okay, we can check how many keys I have. I have only one key now. Okay, see, I have only this key now. If we want to revoke, we can to remove a key. We need to generate revoke key, and then we can distribute the revoke key to our friends. That means it will tell the other friends that this particular key is removed from the list. Okay, so this is the public key look like. Okay, we can publish our public key at MIT or openpgp.org if you like. I'm not really suggesting you to submit your key if you are not very serious in using the key. So don't do this unless you are quite serious to do these things. Okay. Now, we can export a key, the public key, using this command, or okay, let me see if I can. Okay. To export, we need to send this one, the public key block, to the other side. Okay. For example, I want to generate my public key. I can do something like this, but this LSGPG normally binary format, so we'll be having problem when the file is binary format. We can test it. We can test this one. Let me see. So I create a folder GNU PG, and then I can generate my public key. Okay, the public key is generated. The problem is the public key is binary. See, this is binary. Okay, so I cannot read this one. So I can generate the public key into ASCII form by using this command here, armor export. Okay. Okay. Ono at indo.net.id. So I can put this into a text file, and then send this public key block by email to our friends. Okay, so then we can communicate using encryption. This one. So this is we can do manually. If we use this one, we do it by with the help of the Thunderbird. So Thunderbird has built-in encryption facilities. This one, I'll do it manually by hand. Okay. For example, we want to send the public key. Just type this one. There is a menu for attach. Click this menu here. It has my open PGP public key. Okay. So I can send the public key to this one. Public key. So it can be very simple, but I like to show you the real work. See? Okay. See this? Oh, no. Okay, of course. Recipient address rejected, unknown user. Okay, yes. Let me see if I can see the public key here. See this attachment? This one? Open with... sorry. Oh, it will import directly the public key into my key holder. So if I can open using there is no text editor. I have to save the file and then see the using text editor. Okay, but basically the public key looks like something like this. Okay, now having said that, we can import a public key using this command, gpg import the file. It can be text file if you like. Okay, so we can save this into a text file, and then we can import the file, and then we can get this one process. Okay, now that's how import and export of public key. If you want to send someone, then encrypt the file. So normally, this is the problem. I will show you how to do encrypt and decrypt. This one, encrypt and decrypt a file. Normally, people will send an encrypt decrypt file using not encrypt decrypt. Basically, they will send the file to make sure the file is secure enough. Normally, they send using zip or rar, and then they put password in zip and rar. This kind of approach is not reliable, is not secure, because somebody, if there is a hacker can easily hack the zip file or rar file. Okay, I'm not recommending you to send an important file using zip with password or rar with password. If you want to send a very important file and you want to make sure only the destination can read the file, I would suggest to do real encrypt decryption. It's more complex, more difficult, but it's much easier to it's difficult, and it's more difficult for hacker to open the file. The same process happens with ransomware. Ransomware will encrypt all the file, and the hacker will ask for money to give you the key. So this basically same as ransomware. It's very difficult. To encrypt, all you have to do is GPG minus encrypt minus A to make sure the file is ASCII readable, and minus R is the recipient. This is the email of the recipient. We can have several recipients, so it not necessary only one recipient. We can have several recipients and the file. Okay, let me create a file here. For example, we have a test.txt. Okay, this is a test. So we have a text file. Here we have a text file containing the test. So only this one. Okay, let me encrypt the file. Encrypt, make it an armor, so it will save in ASCII form. The recipient is ono@indo.net.id. The file name is test.txt. Okay, so this is the file. To make sure the file is safe in, I think it will generate .asc. Enter. Okay. Let me see. Now we have two files, test.txt and test.txt.asc. Let me see what inside the text.asc. See this? This is the actual message, but it's encrypted. Only ono@indo.net.id can read this message. Okay. How can we decrypt this one? It's quite simple. So GPG minus D, which is decrypt, and the output file is any file, and file.asc. It can be ASCII, which is ASCII, or GPG, which is binary. Okay. Now I will GPG decrypt means output file, which is test.txt. Output file, I will rename anything. This is the output.txt. The actual file is this one. Okay, so GPG decrypt, we can put anything, arbitrary file name in the output file, and this is the actual file that encrypted. Enter. it will ask for password, which is 1 2 3 4 5 6. Enter. Now let me see. Now I have this file. This is the output. This is the output.txt. More. This is the output.txt. So we have this one. Let me see. More. Test.txt, which is the same. Okay. So this is how to send file encrypted, and only the destination can read the file. Now, can we do digital signature here? Oh, we can sign a file and then verify the signature as well. Okay, so we can generate a signature of a file using this one, GPG output the signature and sign the signature. This is the file name, and then this is the signature of the file. We can verify a signature using this method, GPG output doc, and this is the decrypt doc signature. So the file itself, if we want the file to be sent plain text and everybody can read, but we want to make sure the other end can check the signature of the file, we can do something like this. Okay, let me do it. Let us do these things here. Okay, GPG output, this one, we like to generate the signature. So the signature is basically separate from the file. Test.txt, and this is test.txt signature. Okay. By using this command, we actually generate generate the binary signature, basically. Let me see if this is binary. Test.txt.signature. See, it's binary. We cannot read. Okay, it's binary. If we want to make it ASCII, normally I have to type A here. Yes. Okay, let me see. Test.txt.signature. Now it's ASCII. Okay, this one is ASCII form. Now, can we check the this file? All we have to do to check is this one. Okay, decrypt doc signature. Okay, let me do it like this. That one, and then we can type this is after decrypt signature. Okay. So see this, it says good signature from Ono W Purbo, email ono@indo.net.id, and the signature made at 18 March, close to 8 p.m. and so on. So it will show you from the signature, it can tell you that the document is good. Who signed the document? It show you something like this. Okay. Let me check the file itself. This is after, so that's the same thing. So it can check the signature, but also it can encrypt the file. Okay, now if we want to have a detached signature, so the signature is not built into the file, we can detach the signature. We can do something like this. Oops, sorry. Okay, test. Okay, now this one, test.signature detach. Okay, so to make it an ASCII, -A. So make the signature file in ASCII form. Okay, now let me see how it look like. More, detach signature. See this? PGP signature. If we do the using this one, okay, the PGP is not signature. The PGP is message. Okay, this one is signature. If we use this one, message, and if we use this one, is signature. The signature file is detached from the actual file. So we have to send both simultaneously, the actual file and the signature, separate file. So this kind of thing is happening in Privy and many digital signature application in the institutions. Okay, normally they have detached. So the signature is detached, and then the actual file is sent. And the other end can check the signature through the network. To verify the signature, we can type something like this. Okay. Detach signature and the actual file. Okay. See this? Good signature. For example, we can create a random file. Hello, how are you? So this is different file. Okay, let me see if I can. Okay, so this one is different file. Of course, it will it will be very angry because it's different file. See this? Bad signature. So that's how we do these things. Okay, so that's about the signature stuff. I still have about 7 minutes. I have questions. How Alice retrieve Bob certificate? Actually, we can send the certificate by okay. The certificate is, where is the my slide? Where is my slide? My slide is gone. Well, okay. So this here. So Alice certificate is here. It will merge with the actual document when the document sent to the other end to Bob, the actual message, digital signature, and Alice certificate is attached. Okay, and when they decrypt, you can get the Alice certificate. The same thing with Bob. Normally, we are not sending all the certificate. All you need is the public key. You can send the public key by email as well. So when you send the whole message will carry the certificate. But if you send we can send always the public key only. So the other end can decrypt the signature and so on using this public key. Normally, we only need the public key. If both parties know each other, we can send only the public keys. Okay, also. Okay. So that's about the certificate. Now I still have about 5 minutes. I'll show you how to check the signer of a certain website. Okay. Open SSL Bank. We can check the certificate authority of certain website using using this kind of command. Okay, for example, this one. Oh yeah, by the way, if you read the actual act, Information and Transaction Electronic Act, every entity in Indonesia, when they create the digital certificate, it must be signed by Indonesian Certificate Authority. Okay, let's check this website. This is Bank Permata. Okay, we can check the certificate by using this kind of command. Open SSL s_client connect the website port 443. 443 is HTTPS. Okay. Paste. Okay. Now we can see the certificate of the Bank Permata. So basically, it's signed by DigiCert. Okay, the DigiCert, the signature is signed by DigiCert, but the Bank Permata is signed by DigiCert. So certificate of Bank Permata is this one. Okay, it valid until 2026. Okay. It tells you the country is Indonesia. Business category private organization. Serial number is this one. The state is daerah khusus Ibu Kota Jakarta. This is the state, the province. This is the location, Jakarta Selatan. Organization Bank Permata. Name of client is website is this one. Okay. So this this actually violating the law. So the solution is the teacher has to have representative office in Indonesia. That's it. Finished. Actually, but actually the whole server is in US. So if you want to see the actual certificate, is here. Oh, this is the actual certificate. Okay, this is the NO certificate. Let me do it again. See this starter certificate. This is begin certificate. So this is the actual certificate. Okay. It tells you what kind of encryption used for the transaction and so on. Okay, let me see other bank. Okay, click BCA. This is Bank Central Asia. It's signed by same DigiCert. Okay. Oh yeah. To have this kind of certificate, this bank have to pay quite a lot of money actually. So this is not small amount of money. This is a couple of thousand $. So it's quite a lot. Okay. See this BC Bank Central Asia, same DigiCert. Let me see other bank. How about the government bank, BRI? Okay, let me see. Clear. Who signed BRI? So BRI also DigiCert. Okay, so they make a lot of money from us. Don't worry about that. Standard Chartered is international bank. Is it still running? I don't know. I forgot. Let me see if it is still running or not. Oh, okay. It's not running anymore. CMIB. Let me see if this works or not. Okay. No peer certificate. Oh, this is fun. No certificate. That's more brutal than that. Let me see about Tokopedia. Who signed Tokopedia? So we can play around with it and having fun. See this Tokopedia, same DigiCert. Okay, let me see Telkomsel. Who signed Telkomsel? So many of them are DigiCert. See this DigiCert, same. Let's see Kominfo. So actually in Indonesia we have at least BSSN, the Badan National Cyber Security Body, and Kominfo. Both are certificate authority for Indonesian actually. So they have a server for authority, but it seems it's not working. It's not. It's not. Not. It's not working. It's not recognized by the browser. Okay, that's the problem. Let us check Kominfo here. Clear. Okay. See, it's different. Global sign. Still not Indonesian. It's US. Okay. Okay. I think we have a problem here. So this one is not Kominfo. This is cheating. So I would think Kominfo is use CDN, something like that. So this one is not Kominfo. So this is dangerous actually. So this is not the actual Indonesian ministry. So impreva.com is acting on behalf of Kominfo. So, and then okay, 2005, 2006. I think we have a problem here. Okay, well, okay. Okay, let me see. Let me see Kominfo. Change Kominfo use to BSSN. So the main government certificate authority server is BSSN actually. Let's see. BSSN is not using his own certificate authority. It's used the DigiCert US. It's fun, eh? So that's what happened. Wow, 2031. Okay, but still Badan Siber Sandi Negara. Okay, so good enough. Let me see the army. Does it have any? So army use Komodo, which is the cheapest. This is very cheap. This is only what, around $10, something like that lah. $10, $20 certificate. This is the Indonesian Army, and they use the cheapest certificate authority in UK, I think. So this is the Air Force. Okay, let me see. How about the Foreign Affair? Kemlu. Oops. Okay. See this, the difference? Okay, I think we have a problem here. Okay. So Kemlu use DigiCert, but DigiCert is not giving us their certificate. For unknown reason, it's signed by DigiCert, but DigiCert not give us certificate. So but it works anyway. So okay, so all Kemlu use DigiCert, same as BCA, same as the other thing. Let me see if there is a Kemlu around here. Let me see. DigiCert, sorry. I like to check the DigiCert. So if we check the law, the certificate authority must have office in Indonesia at least. It's actually from the law is actually the server must be in Indonesia, but in reality only the marketing office in Indonesia. So that's a little bit cheating. Oh man, seriously? No DigiCert office in Jakarta? None. Wow. Okay. Let me see if there is DigiCert office. Simit. It's not DigiCert office directly. It says sslindonesia.com. So sslindonesia.com is actually using DigiCert SSL certificate. So it changed the name into SSL Indonesia, but actually this is only sales office. The actual server is outside Indonesia. Okay, so that's what happened. Okay, so that's the these things. Let me see if there is any questions. Any questions? There is. Is there any? Is there a way to detect if someone using Wireshark in our network? No. The problem is difficult because Wireshark is a passive sniffer. It's not active. If we do Nmap, we can detect Nmap. If we use Wireshark, the equipment will not able to detect whether someone using Wireshark in our network. So it's impossible. So the easiest way to solve that kind of problem is make sure you encrypt all the traffic. Otherwise, someone will see your traffic. That's it. Okay. Any more questions? No. No more questions. Okay. I have only a couple of minutes, so it's very short. Let me give you some idea what I'm going to tell you maybe next week. So I have tell you about this one last week, intrusion detection system. Today is basic data security, which is encryption, decryption. So hopefully next week I will go to firewall or basic data security, and either these two, firewall and basic data security. These two, maybe I can combine these two, firewall and basic data security. I can combine into single meeting. The problem with these two is I will configure the actual server. Okay, so I will configure server and set the firewall, set the basic server security, and so on. Why we need to see these things? I know maybe all of you is not the server administrator. At least after seeing this thing, you can understand what the person in charge for the server, what kind of thing they have to do and responsible for. Okay, so hopefully it will give you some idea about those things. Okay, any more questions? No questions. Okay. Maybe I need to show you something. I don't know whether I already show you about this. If you want to check my book, you can. Oops, sorry, I need to write again. You can check this URL s.id/free OWP ebooks. I will post this in the chat box. So that's the URL s.id/free OWP ebooks. it will look like something like this. Those ebook related to cybersecurity is this one. Oops. Okay, here. Let me see if I can make it a little bit bigger. Uh, Oops. Okay. See this one? There is an XIT network security. This two is framework to increase the cybersecurity. This one is more policy. This one more technical. Framework is policy. Hacking technical. This one white paper from TikTok. You don't need to read this one. If you want, fine. This one is more strategy, how to make. This is more content oriented, how to make positive content in the internet. This one, the strategy in cyber space. Okay. This one is the cybersecurity framework for e-government, if you like. And then this one is the slide, many of the slide. Let me make it smaller. If you want to play around with artificial intelligence, of course you can download this. This is handbook on AI implementation. This is how to secure AI. So this is AI, but how to secure AI. This one, how to secure AI, and then this is my journal paper on highly secure real count voting. This is in Kawal Pilpres 2019. Okay, so there are several books, and normally about 70 to 200 pages article. You are welcome to download. If you are from institutions, you also need this one, T-shirt. How to manage. T-shirt is cybersecurity internet cybersecurity incident response team. T-shirt, cybersecurity incident response team. How to build and manage T-shirt. Okay, feel free to download and you can read. This is more on management level, but I'm in my class. I normally give the technical stuff. I'm not really talk about the management stuff. You can read management stuff. It's not that difficult. Technical is more difficult. Okay. No more questions? No more. Okay. So I will close this class. Thank you very much. Let's meet again next week. Oh, make sure you do the exam. Okay. We will combine the mark from my class and Pak Arus class. Okay. Thank you. See you next week.
Thank you, sir.
Thank you.
Thank you,
Thank
Pak.
you.
Thank you, sir.
Okay.